Let's go through LeetCode 475 heaters. This question gives us integer array houses in integer array heaters. And let's find the minimal radius of those heaters that can cover all the houses. So let's look at the example 2. So we have a house at position 1, 2, 3, 4, right? And we have heaters at position 1 and 4. It asks what's the minimal radius for these heaters so that it can cover all of the house, right? So from this graph, we'll see in order that a heater will can cover, use some all of the heaters they will have same radius. In order the radius to be smallest, we have to get for every house use its closest heater. For example, for house at position 1, we find the heater is at position 1 is closest, the distance is 0. And the house at position 2, we find the closest heater is also heater at position 1. House at position 3, the closest heater at position 4, and the house at position 4, the closest heater is at position 4. It's meaningless that we have, for example, this house trying to use the heater at position 4. So in this case, for every house, we are going to find minimal distance, right? Find its closest heater and find the minimal distance. So there is everyone it have minimal distance. So the smallest distance radius will be all of this, the maximum of this distance, right? So will be maximal. Yes. So what we are trying to solve is the max of minimals, right? So for each house, how can we get the minimal distance to our heater? We have a heater here, right? So if the heater array is solid, you can use a binary search to find out which is the closest heater to it. And I use a binary search for each house, find the closest distance. And then for that is we get all of the minimums and get a maximum value will be our result. And for this question, one thing to mention is that neither the house nor the heaters are sorted. So we need to sort the heaters, right? Sort the heaters 1, 4. And for every house, we do binary search for a sorted array. So assume this house have an n length and the heaters have m length. The sort of the heaters will be m log m time complexity, right? And for every house, which you will do a binary search on the heaters array, that is log m. And there are n houses, so that is n log m. So the total time complexity will be m plus n log m. Okay. So let's begin to write code for this. Firstly, let's sort the heaters. Always sort heaters. And let's say for every house, we are going to we'll write a function called find minimal distance. Okay. And we'll have the house heaters. So we're going to find the, actually this is minimal, we'll get the maximum, right? So we'll have result equals 0 and result equals max result. Yes. And return result. Okay. And let's rewrite help function. Find the distance. Find the mean distance. And for this house, and we have here as a sorted array. And we'll have start equals 0, and at the perimeters of the length -1, right? So we'll say y start plus and plus 1 smaller than end, right? So we'll have end mid equals start plus end start divided by 2. Okay. So we'll say this, we're trying to find this position, right? So let's say it need the position, need heater position, need heater position equals heaters need, right? So let's say if need heater position equals house at a house position, that means they have same location, you just return 0, right? And let's say if you need the heater position smaller than house, right? That means the closest meter will be on its right? So we are going to looking for the closest heater to the right. So we'll have the start equals mid. And if we need the heater position greater than house, that means our closest heater will be on the left. So we'll have the end. So in the end, we return when we jump out of this while loop, the start index is 1 before the end index. So we are trying to find the minimal distance between the house, right? So this is start heater and heater, trying to find which one is the minimal. So we just need to return mass minimal, right? Mass dot minimal. What we'll get is mass dot absolute value, right? Because we don't know the heater is at the left or at the right of the house, and mass dot another value, right? So the first value will be heater's start minus house, right? The second value will be heater's end minus house. Okay. Position 21. Yeah, we need to have same syntax. Okay, so this is the first approach that we can do binary search. The second approach is that for this house, and this kind of heater, right? Heater. we can have 2 pointers. One will be the house pointer, which will iterate from left to right. Another will be a heater pointer. So we can have full for loops in a outer for loop that will iterate the house. And we'll have some conditions that if the distance j plus 1 to I is smaller than distance j and I, right? Then we'll move the heater pointer. Here, there is something we need to be very careful is that actually this one will use a while loop, okay? And while the distance j plus 1 to I is smaller, I say, or we'll say plus I to j to I is greater than j plus 1 to I, right? Then we'll move the j pointer. And actually, we should have greater equal to, right? Otherwise, there is some kind of scenario that, for example, we have a house that is 4, 5, 6, and heater is always to be 2, 2, 2, for example, 3, right? We'll see if this one and this one, they are same, but if there are a lot of duplicate heaters, it will not move because we don't have equal here. So this is one of the very tricky things we need to think about that. Be very careful that we need to have if j, as long as distance ji is greater or equal to distance j plus 1I, we're going to move the heater pointer so that if there is any duplicates, the heater will move to the largest index, right? Otherwise, for example, you have 4, 6, 5. If the heater is here, right? This J heater is not just compared to the next one, it's not moving. And actually 4 and 5, this will be the closest heater. And because it's just compared to the right, so we'll need to have as long as j and I is greater or equal to j plus 1 and I will move the heater pointer. And in this case, when move jumping out of the while loop, we have the minimal distance between our house and our heater. And then we have a global value to have the maximal global. So let's begin to write code use 2-pointer way. So if we use 2-pointer, we need to sort. Both the house need to sort, right? Sort houses, and both heaters also need to sort. Both the house and the heaters need to sort. So we are going to have let's get its length, okay? So int n equals house length, and m equals meters length. So we cannot use we just use 2 pointers. One will be I, another way is j, because the thing is that sometimes the house pointer will be faster. Sometimes the heater pointer will be faster. So use the right or left is not very appropriate here. So I just use I and j. I represent the house pointer, j will represent the heater pointer. So let's have j at the beginning to be at index 0. So let's say for int I equals 0, that's smaller than n, I plus, right? Let's say while j is smaller than n. And as long as current distance max dot abstract distance heater j minus house I is greater, as we mentioned, we should have a equal, right? As greater equal to max dot heaters j plus 1 minus houses I. In this case, as long as we have this condition, we'll keep moving j, the heaters pointer. So you'll see j plus 1, so we'll have this one smaller than m minus 1, right? When we jumping out of the while loop, for every house, it has the heater with minimal distance to it, the closest heater. So we are going to have int result equals 0. And result equals max dot max, max result, and we are this, and we just return result. Using the 2-pointer, we are sort the house that will be n log n, right? And then also sort the heater will be m log m, right? And that is the 2 pointers. 2 pointers that will be something m or n order, those kind of o n or o m, right? Comparing to this one, we can ignore this. So the term complexity will be n log n plus m log m.